Hello, my name is Tyler Jewell, a member of 4460R Quality Control of Worcester Robotics. For the Educate Challenge, I'll inform you of the design process using my team as an example. The design process. The design process is a series of steps that engineers follow to solve a problem. The process illustrates and organizes the steps that help the engineer come up and test a solution to the problem. For the first step in the design process, we had defined the problem. To define the problem, we would begin by having the problem be identified, validated, and justified. The design requirements and the game rules are then determined and the design brief is created. So for the Vex Robotics, we are tasked with creating a robot for Vex Robotics competition change-up. This game is played on a 12 foot by 12 foot square field. There are two teams that have two robots on each team. Each match has a 15-second autonomous period where the robots drive on their own, and then there's a 1 minute and 45-second period where a person drives a robot. For this game, it's basically like Connect 4 or Tic-Tac-Toe, and we have to be able to move around and score balls into goals. And try to get. For the game, part of generating concepts is to research and find possible solutions to help build your final product. As we begin designing the robot, we would had to figure out bases, lifts, and intakes. When developing the solution, we would have to create a detailed design solution and detailed technical drawings based on the result from our decision matrices. So on screen, you can see how we developed the solution using the matrices. When developing a solution, we have to go over all our concepts and figure out what is the best choice to make. So the bestest way was to use the decision matrices. The decision matrix is used to compare solutions or designs against one another based on specific criteria. Usually points are from 1 to 4, with 4 being the best while 1 being the worst. For these decision matrices, we compared each base and lift based on their simplicity, drivability, space, and practicality and effectiveness. After we finish the decision matrices and figure out the best option based on which idea has the most points, we finally begin developing our solution to move in the stage of creating a prototype. The half pipe and hollow mount C-base won the decision matrices for us, so we created several sketches to show what our ideas were to start building. After developing a solution, we move on to constructing and testing a prototype. After creating a sketch and finalizing our design, we would begin to build a testable prototype. Then we would have to test it for performance, usability, drivability, collecting the data, analyzing the data, and creating the test report of the findings to see whether or not the design is useful. After constructing and testing a prototype and finding the best results, we evaluate the solution. The final step of the design process is to evaluate the solution, so we have to evaluate the final effectiveness, redesign problems to fix later, and reflect on our solution. With our final robot, our design has been great and reliable. It's proved its great solution to the game by being able to be us qualified to states and worlds, being able to complete the autonomous challenge and skills challenge, and being able to consistently score in the match.
After evaluating the solution, we then present the solution to others so that they can verify and replicate our results.